Sprites in a game can be described by the location and movement on the screen. Your job is to figure out how we can describe the actions of these sprites mathematically in relation to the coordinate plane. There are a few things we need to know about them in order to make the game work. First, we need to know which direction they're moving. Second, we need to know where they are on the playing field. Third, we need to know how far apart they are. As a player of a game, you might say in general terms that they are on opposite sides of the screen. Or that you might say that sprite 1 is moving to the right. Or that they're pretty close to each other. These might be okay approximations, but they really aren't specific enough, and they definitely aren't something a computer can understand. Suppose you're talking to your friend on the phone and are trying to tell them exactly where the sprite is. You can use words like on the right, but that isn't specific enough. If we add a number line, like the one shown here, we can stick the sprite anywhere on the line and measure the distance back to the left side of the screen. We can say the sprite is at 8 and the burger is at 18. We can say the sprite is moving from 8 to 14. This way we can have specific ways to describe where the sprite is on the screen. However, what if the sprite is at the top of the screen, or in the middle of the screen, or even at the bottom of the screen? It's very difficult to tell exactly where the sprite is in the up and down space on the screen. By adding a second number line, we can locate the character anywhere on the screen in either dimension. The first line is called the x-axis, which runs from left to right. The second line, which runs up and down, is called the y-axis. A two-dimensional coordinate consists of both the x-axis location and the y-axis location. To locate a sprite's position on the screen, we can find the x-coordinate by dropping a line down from the sprite and read the position on the number line, and the y-coordinate is running up the side. So if I was to move my sprite here, it is at 10 on the x-axis and 8 on the y-axis. So the coordinate written in xy form is 10, 8. However, if I was to move my sprite here, it is 4 on the x-axis and 10 on the y-axis. So it would be written 4, 10. X is written first every time. What we have actually created here is quadrant 1 of a coordinate grid. If we zoom out, we will see that we were working in this quadrant 1 of the coordinate grid. In this quadrant, the x's are positive and the y's are positive. In quadrant 2, if we go around counterclockwise, in quadrant 2, the x's are negative, but the y's are still positive. Quadrant 3, the x's are negative and the y's are negative. In quadrant 4, the x's are once again positive and the y's are negative, which means that all points on this coordinate plane will be listed as either positive or negative, depending on which quadrant this sprite is moving in. This is what the coordinate grid looks like in Scratch. We are now able to tell exactly where the sprites are on the background based on their coordinates on the coordinate grid. For instance, the cat sprite is in quadrant 2. He's in a positive y, negative x quadrant. So when we write it out, x comma y, it would look like this. So he's at negative 100x, positive 100y. The hamburger that he's trying to get to, however, is in a positive x quadrant, negative y quadrant, quadrant 4. So he would be, or it would be, at 100x, negative 100y. We can place things on the grid with this, but we can also use this to code their direction and movement across the screen.